Hi everyone, this is Praktis Formatif of Chapter 4, question number 13. In this question, we need to solve the following permutation questions involving identical objects. So if we need to involve the identical objects, so we may have NPR or NPN, doesn't really matter, but we have to divide by the numbers of the identical objects. So there could be the M factorial, it could be P factorial, Q factorial, so on and so forth. Depends on how many identical objects are there. So let's look at part A, part 1. So we need to rearrange the letters that made up from the word lookout. So out of this, we will have 1, 2, 3, 4. 4 letters. Okay, plus with 1, 2, 3, 3 repeated letters, 3 O. The rest are just the normal or single letters, but O it repeated 3 times. So in this case, we shall, since we arrange all, so all in all we have 7 here, right? So 7 factorial. We have to divide by the 3. Okay, 3 factorial because O appeared 3 times. So we divide by 3 factorial. So with that, let's use the calculator. So we shall take 7 factorial divided by 3 factorial. $840. Okay, so there's 840 ways to rearrange this letter. Part B. From the word mathematics, okay, I see that we have 2M and then 1A, 2 A's. Okay, anything else? T. 1 T, 2 T's. And any more? We're left with H, E, I, C, S. So the remaining are the single letters. So how many of them? 5 of them. So 5, the rest. Okay. And therefore, all in all, we have 11 letters here. Let's double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have 11 letters. So 11 factorial divided by, now MAT. They are the identical items. So we divide by the M, 2 factorial, divided by the A, 2 factorial, divided by the T, 2 factorial. Okay, so let's get the help from calculator. Okay, 11 factorial divided by, put bracket, 2 factorial times the 2 factorial and times another time of 2 factorial. Okay, so the answer is 4,989,600 times. 4,989,600 ways to arrange these letters. And part C, Mississippi. Okay, we have 1M, all right. And then for I, we have 1, 2, 3, and 4. So we have 4 times of I. For S, right? For S, we have 1, 2, 3, and 4. 4S. 4S. And then for P, we got 2 P's. Okay, and the only one that is not repeating is M. So we have 1 M. So all in all, we have 11 letters. Double check. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, correct. Therefore, again, we have 11 factorial over 4 factorial, 4 times of I, 4 factorial for 4 times of S, 2 factorial for 2 times of P. So with that, let's use the calculator. All right, use the previous one, 11 factorial divided by 4 factorial, 4 factorial, and then divide by another 4 factorial, and divide by another 2 factorial. Therefore, the answer is 34,650 ways. Okay, 34,650 ways to arrange Mississippi. So that is part A. Oh, part 1, part 2, and part 3. Okay, let's move on to part B. So for B, we have to find the number of ways to form 5-digit numbers from a card that are labeled with, okay, we have 1, 1, and then 3 times of 2. Okay, and then the rest are 1. So we have 1, 2, 3, 4, 5, 6, 6 others number. And then for 8, we got 2 times of 8. All right. Now this time we don't arrange all. We arrange partial of it. So there are some condition to this. So I will use fill in the slot method. So 1, 2, 3, 4, 5. Now the question also mentioned that if all the digit 2 must be used. Since 2 must be used, so 3 out of 5 empty slots is used up. We're left with 2 empty slots to fill in. Now, it's either we fill in the rest of the numbers, or we may fill in 2 times of 8. So therefore, we have all 2s and all 8s. Okay, first scenario. The second scenario will be all 2, okay, because 2 must be included, and we may have 1, 1 8, 1 others. Scenario 3, so all 2 and 2 from the others. 3 scenario here. Which I can combine scenario 2 and scenario 3, but never mind, I just show one by one. So for the scenario 1, all 2s must be in. So the 2 will choose out of the 5 empty slots. Okay, we choose any of the 3 to fill in the 2. And don't forget, we have to divide by 3 factorial because 2 are identical. And followed by the remaining 2, we will just have 2P2 because we have 2 8s. So out of these 2, we just arrange the 8 in. And don't forget, we have to divide by 2 factorial because 8 appear twice. This is the first scenario. So let's get it done first. Let's count the value. So we have 5P3, 5P3. And then we divide it by 3 factorial and followed by times 2P2 divided by 2 factorial is actually 1 because 2P2 is actually 2 factorial. All right, so well, just key in. They're not so sure. So 2P2 divided by 2 factorial, actually we got 1. Therefore, the answer is 10. So there are 10 ways to have the first scenario. So for the second scenario, again, we have all 2, so 5P3 over 3 factorial and 1 8. Assume that 8 must be in. So out of the remaining 2, we just choose any of the empty slot to fill in our 8. So we left with one empty slot. Okay, the remaining one empty slot, we have how many choices to put in others number? There are 6 others number for us to choose from. So we just choose 6, choose 1 to fill in the last empty slot. So let's use the calculator. So we have 5p3 divided by 3 factorial, followed by 2p1, okay, followed by 2p1, and times 6p1. So we have 120 ways to get the second scenario to occur. And the third scenario, so again, 5p3 over 3 factorial, and then the remaining 2 empty slot, we choose from the others, no 8 is involved. Therefore, it will be 6 others number. Out of it, we just choose 2 to permute in the remaining 2 empty slot. So over here, 5p3 over 3 factorial, and then followed by 6p2. So 6p2. Okay, the rest we delete. All right. 300. So we have 300 here. Therefore, all in all, the number of ways to arrange 5-digit number. Okay, that will be 10 plus 120 plus 300. So we have 430 ways. That's it. Okay, so that's all for question number 13.